Hi, this is Kumar Singh from Design Analytics LLC, and you are watching another episode of Thursday Throwbacks. Right. So, as I have kind of touched upon in many posts since this morning, or actually starting last night, we are going to touch upon Markov chains. Right. Before we get into understanding the history of Markov chains, we need to understand the significance of Markov chains. Right. The significance of Markov chain lies in both its theoretical foundations in probability, in the world of probability, and the wide range of real world applications. But let's try to look at it from few different or three key different areas. So first one is the conceptual significance, right? It has a memoryless property. It formalizes the idea that the future depends only on the present, not the past, as represented by this formula, right? And this simple principle actually captures many natural and man-made processes, making them easier to analyze, right? Then you have foundation of stochastic processes, another key conceptual significance of Markov chains, right? Because they are the building blocks of modern probability theory and stochastic modeling. They are bridge between theory and application, as they provide a tractable framework where complex random systems can be studied mathematically and applied directly. And then the second bucket is mathematical importance, right? Stationary distributions. So over time, many Markov chains converge to a steady state distribution, revealing the system's long-term behavior, right? For example, the steady state of a queue. Ergodicity and mixing. So Markov chains are key in proving law of large numbers for dependent variables, which was the original motivation of the person who came up with this series, Andrei Markov. Right? And they are basis for Monte Carlo methods, as we touched upon in a post this morning, right? They have a wide range of practical applications, right? So mathematics and computer science, right? We know they can be leveraged in natural language processing, reinforcement learning. They were at one point, I'm not sure if they still are, used for Google page ranking, right? They are used in the field of AI and machine learning, like hidden Markov models or sampling algorithms. They are used in economics and finance, natural sciences, engineering and operations research. So very wide gamut, and that is what makes Markov chains significant. As we touched upon, Markov chains where the concept was postulated by Andrei Markov, right? A very bright boy since childhood. He had some disability in the childhood. I think he couldn't even walk without crutches till he was 10, but a genius, started writing math-focused research papers, specifically differential calculus focused papers very early on while in his teens, and was kind of noticed by some of the leading mathematical scholars at St. Petersburg University, who invited him. He studied there. He eventually joined the faculty, right? The physics and mathematics faculty at St. Petersburg. And he was the person who came up with the idea of Markov chain, or not exactly the idea, but Markov chain, right? So in words of Sergei Bernstein, who basically kind of continued to develop the theory of Markov chain, that's his quote, that Markov's classic course on the computation of probabilities and his original memoirs, Models of Accuracy and Clarity of Exposition, contributed to a very large extent to the transformation of the theory of probability into one of the most perfected areas of mathematics. I'm reading the quote. And to the wide dissemination of Chebyshev's method and directions of research. His profound analysis in the spirit of Chebyshev of the dependencies among observed random phenomena allowed Markov to extend probability theory in an essential way through the introduction and investigation of dependent random quantities. So sorry for that distraction, but I was just reading the quote from another paper. So with that background, right? With that background, let's get into the history aspect, right? So what you see here is the historical timeline, right? So before Markov chains, there was this work done in the field of stochastic processes, right? And that kind of laid the foundation, the groundwork, right? So for example, probability theory, which was formalized in 17th century, right? Laplace developed early stochastic models and introduced generating functions. Every electrical engineer should be very much familiar with Laplace transformation, right? Poisson, he studied events over time, Poisson processes, Poisson distribution, right? So these work laid the groundwork for studying stochastic processes, but were not yet about dependent sequences. And then comes Andrei Markov, right? So Russian mathematician, right? Student of Chebyshev, right? That was the person that was mentioned in the code. Again, if I butchered the name, I apologize. So around 1906, Markov was very interested in extending the law of large numbers to sequences of dependent random variables, and that's when he introduced the idea of a chain of random variables, right? A chain of random variables where the probability of the next state depends only on the present state, which is called the Markov property, formally represented like this. Then around 1907, we had the famous first example where Markov analyzed Pushkin's poem. And he studied one specific poem actually, right? And he studied sequences of vowels and consonants, right? And then he, I think essentially it was V and C, represented as V and C in the work that he presented, and he constructed a transition probability matrix between V and C. And that showed how Markov chains could model dependent sequences in language. Well, this was revolutionary. Why? Well, because most probabilists focused on independent events, while Markov showed how to handle dependence systematically. Then comes the early development phase, 1910s to 1930s, right, where Markov chains became a branch of probability theory, and they were studied at that time mainly in Russia and then later in Europe, right? Then another mathematician, Andrei Kolmogorov, he worked on it. He took the work forward, formalized probability theory with measure theory, and developed Kolmogorov forward and backward equations for continuous time Markov processes. And that led to modern stochastic process theory. Then comes the mid 20th century expansion, right, where Feller spread Markov chain theory in the West through his book An Introduction to Probability Theory and Its Applications. Dueblin in 1930s contributed key results on ergodicity and limiting distributions. There were applications during World War II in operations research, queuing model, and reliability of systems. Claude Shannon, 1948, used Markov chains to model English language sequences in his foundational work on information theory. If you have not, you must see the episode on Claude Shannon that we covered in Throwback Thursdays and the history of information theory. Okay. And then comes the modern application, 1970s to present, where statistics and machine learning leverage Markov chain Monte Carlo methods, right? And like we touched upon in the beginning, we covered them. The Markov chain methods are leveraged across many different areas like economics, computer science, physics, biology, and finance. Well, I hope you liked the episode. I will see you again next week.